In this video, I'm going to show you how to solve a polynomial through the use of the rational root theorem as well as synthetic division and your graphing calculator. I won't be able to show you what I'm doing on my graphing calculator, but I can at least talk you through it so you can see it for yourself. Okay, so I chose to do one of the problems off of the practice for the solving polynomials, the notes that are entitled synthetic division and the rational root theorem. Okay, so what I'm going to start off by doing for this one is finding all of the potential rational zeros of this function. So what that means, I can make up a list of all the possible fraction and whole number values that this graph could cross the x-axis at. And that's just going to kind of help us kind of pinpoint where it crosses the x-axis so that we don't have to sit there and check a bunch of different roots and waste a bunch of time. Okay, so the rational root theorem states that if you take p, which in this case is 141, and write out all of the numbers that divide it, so plus or minus 1, plus or minus 3, plus or minus 47, and last but not least, plus or minus 141. And then you take q is your leading coefficient, and write out all of the numbers that divide that, so plus or minus 1, plus or minus 5, and then you put them together in fraction form, p divided by q. So you're going to take every p value and divide it by every q value. So be careful about this. I'm going to write it out the long way first. So right now I'm just taking every p value and dividing it by 1, which is the first q value, and then I'm going to do it again, but divide it by the second q value. This method can be kind of tedious if you have a number that has a lot of roots, like 24 or 60 or something that just has like tons and tons of numbers in the list that divide it. But in a case like this, once you get the hang of it, really it's pretty quick. Alright, so if we simplify this, the only possible rational roots for this are 1, 3, 47, 141, that's a plus or minus sign, 1/5, 3/5, 47/5, and 141/5. From this point, you're going to go ahead and graph it in your graphing calculator, and make sure you're looking at a standard window, so -10 to 10, and then you're looking right in front of you, the 1, 3, this list is all of your potential rational roots. So those are the numbers that we have to use in order to use synthetic division. So we have to choose a number from this list where it crosses the x-axis. So when you graph it, it looks like it crosses the x-axis 3 times, which is good. That means you have 3 real solutions, which means you're not going to end up with an I, or complex number, in your solutions. But keep in mind, those 3 real solutions don't necessarily have to be rational. So, for example, it could cross at something like square root of 5. Square root of 5 is a real number, but it's not rational because you cannot write it in rational or fraction form. So when you graph this, you can see it crossing the x-axis in between 0 and 1. And what I would do is, from this list, look at your fractions, or look at the numbers that are close to around 0 and 1. We have 1. Well, but if you look at the graph, it doesn't really look like it's crossing at 1, so I wouldn't need to test that one. But we have 1/5 and also 3/5. So that just really narrows it down for you. Whether you go to the table and type in an x value for it to test, or if you hit on the 84's second trace and then option number 1, value, and type in the x coordinate that way. But either way, you're looking to find the point exactly where it crosses the x-axis. Now for this one, our winner, shall we say, is 3/5. So 3/5 is going to be the number that we use from here. So again, just to recap, we do p over q just to get a finite list of numbers that it could possibly be, and then we graph it. So with the graph, we use these lists, these numbers, to kind of guide us in our selection. Once we find that number, then we can go ahead and use synthetic division, which we'll do on the next page. Alright, so I recopied the original polynomial so we could so I could remind you where the numbers for synthetic division come from. So 3/5, that was our winner. That's where it crosses the x-axis. So across the top for synthetic division, I'm going to write 5, negative 73, 277, and negative 141. Alright, so make sure you take the signs with the coefficients. Okay, so now here we go. Alright, for synthetic division, you always start by dropping down the first term. So it's a 5. And then you're going to take the number that's in what I call the box, and you're going to multiply it by the number that's below the line. So 3/5 times 5 is a positive 3. And that number just goes in the next spot up underneath the next term. From here, we're going to add these numbers down. So negative 73 plus 3 is a negative 70. And then we repeat that process. 3/5 times negative 70 is a negative 42. Add 277 and negative 42, so 235. And then do one last multiplication, so 3/5 times 235 is a positive 141, and we get a 0 here. That 0 is really important. That 0 tells us that 3/5 definitely is a root of the polynomial, which it should be, as long as you picked the right one. And if you don't get a 0 there, and you know for a fact that across the x-axis is the number that you had in the box, just go back and double check a couple of things. Most common mistakes are sometimes people forget to bring down the sign that's in front of a term. So for example, if you put a positive 73 instead of a negative 73 up there in the top, or sometimes you just kind of do the multiplication wrong or you add wrong. So just kind of do a double check of those little things, and that should help. Alright, so from here, we're going to take these numbers and we're going to fill them back in with their variables. Every time you do synthetic division, it's going to decrease the leading coefficient's exponent by 1. So up here, we had 5x to the third. So we're going to decrease that by 1, and that makes this first term 5x squared. And you just follow suit for the rest of them. Minus 70x plus 235. Oops, 235 is equal to 0. Okay, so from here, anytime you do synthetic division and you get it down to a squared term, you don't really need to do synthetic division again. With anything that's squared, so quadratic, you can either use completing the square or the quadratic formula, or you could even try to factor it. So before I try to do either of those, I really don't like the numbers that I'm dealing with right now, the 5, the negative 70, and the 235, but all of them are divisible by 5. So I'm going to start by doing that before I decide what method to use. So if you take out a 5, we'll have x squared minus 14x plus 47 still equal to 0. And then we really just need to worry about dealing with that. When I look at that, I see a 1 out front because we don't need, the 5 is kind of, we're done with the 5. We've factored it out. It's not going to change the value of our solutions at all, so you can kind of, in a sense, just ignore it. So I see a 1x squared and an even number in front of that middle term, so I'm going to go ahead and complete the square. So, but if you want to use quadratic formula, have at it. Just make sure that at the end you've simplified it as much as you possibly can. Alright, so x squared minus 14x plus box is equal to negative 47 plus box. Alright, you're going to take half of the middle term, so negative 7 squared, and I'm running out of space, but negative 7 squared on the right side as well. In the next step, you're going to take the squared terms and put them together. So x minus 7, the quantity squared. And then over here, negative 47 plus 7 squared is going to give you, let's see, your positive 2. And then we can square root both sides. So we have x minus 7 is equal to plus or minus radical 2. There's that irrational number. There's where that irrational root's going to come from. Get x by itself. So the other two places where it crosses the x-axis are at 7 plus or minus radical 2. Now you could use your calculator to get a decimal approximation for those. And if you look back at your graph, those decimals should match up with what you're seeing, like where it's crossing the x-axis the other two places. But again, here's an example of all real solutions, but not all ones that are rational. So x plus or minus radical 2 are going to be two of our solutions for this polynomial, as well as 3/5, the number that we found at the beginning. So when it's all said and done, those are your three roots.
Made with Doodlecast Pro.